Right. This is the question from complex numbers asked in the morning session of January 10th. See, the problem is also involved with the basic definition of the modulus of the complex number. In the question they mentioned that 2z1 is equals to 3 mod z2 and 2z1 by 3z2 plus 3z2 by 2z1 is equals to z. And we need to identify one among these four options. See, it's clear that 2 mod z1 is equals to 3 mod z2. See, since 2 mod z1 is equals to 3 mod z2, if you square on both sides, what we have? If you square on both sides, from there we will get that 4 mod z1 square is equals to 9 mod z2 square. And we are aware that mod z1 square is nothing but mod z1 bar, and in this side 9 z2 bar. Now see, another expression given in the question is 2z1 by 3z2, 3z2 by 2z1. By observing these two, what I am going to do is I will split it like this: 2z1 into 2z1 bar is equals to 3z2 into 3z2 bar. Clear? Now, see, since it is 2z1 by 3z2, so 2z1 divided by 3z2. 2z1 by 3z2 is equals to, on this side, 3z2 bar by 2z1 bar by rearranging this. This is 2z1 by 3z2 is equals to 3z2 bar by 2z1 bar is nothing but 3z2 by 2z1 bar. So this 2z1 by 3z2, the first one is nothing but 3z2 by 2z1 bar, which is nothing but conjugate of the second term. So this term and its conjugate, sum of these two. So if you consider this 3z2 by 2z1 as some capital Z bar, this is capital Z bar plus this is that capital Z is equals to Z. A complex number and its conjugate. If this complex number is some a plus ib, then its conjugate is a minus ib. Sum of these two is 2i, which is purely real. So Z is purely real and its imaginary part is 0. So the correct option for this question is imaginary part of Z is 0. There is the question. So once again, if you observe, 2 mod z1 is equals to 3z2 square on both sides. 4 mod z1 square is equals to 9 mod z2 square. See, mod z1 square is nothing but z1 bar. So a clear property of the modulus. And then mod z2 bar is nothing but z2 bar. See, 4z1 bar is expressed like this: 2z1 into 2z1 bar, 3z2 into 3z2 bar. Now, see, 2z1 by 3z2 is equals to 3z2 bar by 2z1 bar. Again, one more property of the modulus: 3z2 bar by 2z1 bar can be written as mod 3z2 by 2z1. Now, in the question, 3z2 by 2z1 plus 2z1 by 3z2. See here, what I have 2z1 by 3z2 as 3z2 by 2z1 bar, which is the conjugate of this second term. If you let the second term as some z, this is z1 z bar. So z bar plus z is the given complex number z. See, this is a complex number and its conjugate. Sum of these two is always a real. So z is a real. So its imaginary part is 0, and that was your option. Thank you.